Today we will discuss exploring differential equations. Part 1. Why differential equations? Which means what is the purpose of differential equations and why are they so important? We will discuss in detail some of these questions. Where do the differential equations come from? The differential equations arise from the verbal statements describing rates of change of quantities. For example, the value of your house may be increasing at some constant rate. This statement will be written as a differential equation as shown below. A. Knowing the value of your property P today and assuming a suitable rate of rise per year, you will be able to know its value in any future year by solving the following differential equation and using it. The differential equation to solve is dp by dt is equal to k, or dp is equal to k dt. Or integrating both sides, we get p becomes equal to integral from 0 to t of k dt, or p is equal to kt plus c, where c is constant of integration used with all general solutions. First order differential equations will have one constant, whereas second order differential equations will have two constants of integration, and so on. The time rate of change of a quantity may be proportional to the quantity itself. Then the differential equation to solve will be dy by dt is equal to ky, or dy by y is equal to k into dt, or integral of dy by y is equal to integration from 0 to t of k into dt, or ln of y is equal to k into t plus ln of c, where the constant of integration is written as ln c for convenience. Here we find that on the left hand side the quantity y has ln. Therefore it will be easy if we use ln c as a constant in such problems where left hand side involves ln. In this case it will not be c but ln c instead. C. The time rate of change of a given quantity may be a given function of time. Then the differential equation may be dy by dt is equal to ft, that is some function of time. The solution of this can be found when the function ft is defined. The constants of integration are evaluated using the known conditions associated with the problem. Such a solution is called a particular solution. Let us now solve an example. Suppose you purchase furniture worth $25,000 today. After 8 years, it will become scrap worth $500 only. At what rate are you losing your dollars per year? What should be the price of your furniture after 4 years? Assume that the rate of loss is proportional to the value of the furniture at any time. Here it may be seen that the problem translates to the differential equation dy by dt is equal to minus ky, which when solved using the given conditions will yield the solution to the problem posed here. Here y is the value of furniture at time t and k is annual rate of loss. Minus sign is for the reason that value is decreasing and not increasing. The equation is rewritten from here in this form. Integration will give 1 over y dy integrated is equal to integration from 0 to t of minus k dt plus ln of c. Ln y is this, and minus kt plus ln c, this integration is written down here. This may be written as a new equation. Ln y minus ln c is equal to minus kt, or ln of y by c is equal to minus kt, or y by c is equal to e raised to the power minus kt, or finally y is equal to c e raised to the power minus kt, which is the general solution. To evaluate constant of integration c, we substitute in the solution the fact that at t is equal to 0, y is equal to 25,000. This means that 25,000 is equal to c into e raised to the power minus k into 0. T is 0 now. This is equal to c because this quantity becomes 1. So we see that the particular solution is y is equal to 25,000, which is c, into e raised to the power minus kt. Compare. This is the equation with now c evaluated as 25,000. After 8 years, 500 is equal to 25,000 into e raised to the power minus 8k, or e raised to the power minus 8k is equal to 500 or 25,000, which is 0.02. Taking ln of each side, we get minus 8k is equal to ln of 0.02 is equal to minus 3.912. Therefore, k is equal to minus 3.912 divided by minus 8, which is equal to 0.489. To evaluate constant of integration c, we substitute in the solution that t is equal to 0 at y equal to 25,000. This means that 25,000 is equal to c into e raised to the power minus k into t, which is 0. This is c. This particular solution is therefore y equal to 25,000 into e raised to the power minus kt. This is now a particular solution because the general constant of integration has been evaluated by using the given condition $25,000 at time t is equal to 0. So after 8 years, we can write this equation as this by substituting 8 in place of t. So what we have is e raised to the power minus 8k divided by 500 over 25,000. This is actually 500 divided by 25,000, which is 0.02. Taking ln of each side, we get minus 8k. Ln of this is equal to ln of 0.02 equal to minus 3.912. This gives k equal to minus 3.912 divided by minus 8 equal to 0.489. Thus finally we have this solution. After 4 years, y will be equal to e 25,000 into e raised to the power minus 0.489 into 4, which is this, equal to $3.3536. That will be the money left from your 25,000 investment in your furniture. Thank you so much.